Okay, so the next topic that we want to actually revise is on overflow. So before we proceed, what is overflow? What is overflow? What do you all think? What is overflow? Can give a wild guess. More than the 8 bits. So like just now when we perform addition, we get that more than 8 bit, that is overflow. Any other definitions? Okay, fine, that's a good try, but that is incorrect. Overflow has a different meaning than what you thought it was. So overflow means and overflow only can occur in 2's complement number system or with signed number system. Okay, excuse me. Overflow in a simple term is when you add 2 signed number in the answer you're getting a wrong sign. For example, positive number plus with positive number is supposed to get positive, but if you get negative, which is the wrong sign, that is overflow. Is that okay? Negative plus with negative is supposed to get negative, but if you get a positive answer, that is overflow. So overflow means getting the wrong sign. So what if we have negative minus negative? Can be negative, can be positive, depends on which number is larger, right? So likewise with the positive part. So overflow in essence means getting the wrong sign. That's all what it means. And overflow can only occur with addition and subtraction in 2's complement number system, the signed number system. So it occurs when the result of 2 numbers gives out the wrong sign. Is that okay? So there's a hint which I have given here. In addition, overflow may occur with the same or like sign, which means if you're adding 2 positive numbers or if you're adding 2 negative numbers, there are possibilities of getting an overflow. But if you are adding unlike signs, positive with negative or negative with positive, if you're adding unlike sign, it is impossible to get overflow. I didn't write that part, so this is where you should write your own notes. In subtraction, overflow may occur with an unlike sign. So if you are subtracting unlike sign, positive negative or negative positive, you may get overflow. But if you are subtracting same sign, like signs, it is impossible to get overflow. So let us see some examples here. Does overflow occur in the following 8-bit operation? Now these are some of the terms which abbreviation which I have written. So if you don't understand the abbreviation, just do let me know. So we have 3 examples here. So the first one is a subtraction operation. Now based on the hint, if you are subtracting like sign, here's like sign, right? How do you know it's a like sign? This is positive, this is positive, so it's the same sign. So if you are subtracting same sign, is there a possibility of getting overflow? It is impossible to get overflow. Well, that is Prajin's hint only. So how do you know? So let's try. So let's perform the subtraction. So 1 minus 1, 0, 0, 0, 1, 1, 1, 1, 0. How do we know whether this is overflow or not overflow? Because here we have positive minus positive supposed to give you what? How are you supposed to know it's positive? You know, right? This negative and positive becomes negative. So it depends on which positive number is larger, right? That will determine the sign of the answer. Now look at these two numbers. Which one of these is a larger positive number? The first one. How do you know? Just by visual inspection you can see that the first digit has more number of ones, right? Here is actually less. This is 7, positive 7. This is positive 1, 2, 7. So this is a larger positive number. Minus is a smaller positive number. So you're supposed to get positive. Are you getting positive? So it is the correct sign, right? So therefore there is no overflow. Yeah, I told you, right? It's impossible to get. So now only just one example, but you may try. The hint is just as a guide. You may try. Any question on this? Able to follow? Don't worry about writing down. If you have understood, then you write down. If you don't, ask question. Shall we see the next example then? The next example, we are performing addition. So what was the hint on addition? Now first of all, let us see, is it the same sign? Yes, it is the same sign. So what does the hint say about adding same sign? May occur, right? But it say may, not will occur. May, possibilities, but we have to check. So in this case, this is positive plus with positive, definitely supposed to get positive. That is for sure, right? So let us see, are we getting positive or not? So you have 1, 1, 0, 0, you get 2, you get 3, and becomes 1. So do you see that now this is negative? So it is the wrong sign, and therefore it is overflow. So remember, overflow got nothing to do with the answer. It is just reflective on the sign, if it's wrong sign or not. Any question up to this point? Can we try another example? Let us see this one. This is subtraction with unlike sign. So with unlike sign, what is the hint? May get overflow. So this is a negative number minus positive. So you will get, definitely this is confirmed, you're supposed to get negative. So let us see, are we getting negative or not? So this is 1, this is 0, this is 0, this is 0, this is 0. So here you have to borrow. So how much are you borrowing? So this becomes 0, you're borrowing 2. Then you have to borrow again, so this becomes 1, this is 2. So 2 minus 1, 1, 1 minus 1, 0 and 0. So look at the sign. You're supposed to get negative, but you're getting positive. So it is the wrong sign, and therefore overflow. So in test they will ask you all this. They may ask you. So you have to justify why there is an overflow. So just like how we are doing, I did mention, right, I get positive, it is incorrect sign, by right supposed to get. So you see how I am justifying. So that's how you should justify as well. Any question up to this point? Is it clear? So for the recording part, I'm going to continue this overflow topic with the final topic, which is the binary coded decimal, because this is relatively very short and simple, so I don't want to make a separate video for that, so I'll just combine together with this. Is that okay? So the last revision that we're going to do for this number system is BCD, or known as the binary coded decimal. So what is binary coded decimal? From the name itself we know that each decimal digit is represented by a 4-bit binary number. So we have here the decimal values from 0 until 9, right? These are the ranges of decimal number. Each one of this decimal number is represented by 4-bit binary number. So you know each one of this binary has weightages, right? 1, 2, 4, 8. So if it's 0, what is the BCD value? 0, 0, 0, 0. If it's 1, 0, 0, 0, 1. If it's 2, 0, 0, 1, 2. Until it reaches 9, it is 1, 0, 0, 1. So this is the binary coded decimal. Now we will actually be using this BCD later in chapter 7. In chapter 7 we will revisit this back for 7-segment display. Do you know what is 7-segment display? It's a display which has 7 segments. 7-segment numbering in banks we have seen, right? So we will be using BCD format to represent numeric numbers in chapter 7. So with that we have concluded with this chapter of numbering system. Any questions that you have so far?